Okay, here we go. So we are starting our next unit today. We're going to be focusing on solving polynomials. So all the same things that we did in our last unit, we're going to see in this one as well. The difference will be our focus. So in our last unit, we were focused on where's the vertex, where are the x-intercepts, what do the x-intercepts look like, where's the y-intercept. In this unit, we're still going to care about those things, but our focus is going to shift from find these features on the graph, or what would this look like on the graph of the function, to what would be the solution here, or if I'm using this polynomial to model a particular context, what would happen when this is my x value, or when will I reach this amount that I'm interested in. So we're going to take a look at solving and modeling with polynomials in this unit. We're going to start with stuff that we've already seen. So we're going to start with degree. So that's the first thing we're going to identify for our first couple of problems here, the degree of these functions. So what's the degree of my first function here? 2. It's in standard form. The degree is going to be that biggest exponent. What's the degree of my next function here? 3. This one's in factored form, so we add the exponents. 2 plus 1 would be 3. How about my third function? 2 again. This next guy? 4. And the last one here. Add the exponents. 1, 2, 3. Okay. Now let's find the x-intercepts. So for our functions in factored form, you should be able to identify the x-intercepts from factored form. So if I take a look at this guy here, what would be my x-intercepts? -2, 1, and 4. And then how about this guy? What are my x-intercepts here? 1 and -3. And since the factor that I'm getting 1 from is squared, that actually means I would have 2 of them, right? Because that multiplicity is 2. I would see a bounce there, or a quadratic behavior at that x-intercept, right? Because I have that multiplicity there. For the rest of these, we're gonna graph to find our x-intercepts. So I'm gonna pull up my calculator, and we will graph these functions to find our x-intercepts. So our first one is x squared minus 4. So I'm going to grab my calculator here. I can find my cursor. There it is. And this is the guy that I want. So I'm on a graph page, ready to type some stuff in. And I want x squared minus 4. There's my graph. I can see my x-intercepts on the graph for this one. But in case I couldn't, or if I wanted to double check, remember we would go to Menu, Analyze Graph, and these are called the zeros when I look for those x-intercepts. So I have an x-intercept at -2, and then the bummer is we can only find one at a time. -2 and +2. So my x-intercepts for that first function are -2 and +2. My next function in standard form is that third one down, x squared plus 3x plus 2. So I'll graph that. You can make a new graph. You can graph a new function on the same page. I'm going to go ahead and edit this one. So I've got x squared plus 3x plus 2. It just sort of shifts that function. And it looks like I still have an x-intercept at -2. And then I'll find the other one. Menu, Analyze Graph. 0. Looks like -2 and -1 for that third one. And then just to kind of review the skill, I'm going to add a new page for this next one. So I'm going to do the blue control button and then dock to add a page. And I'm going to add a graph. And I'm going to graph that next function. So this would be x to the 4th. I have to use the caret key. Don't forget to arrow out of that. Minus 3x, caret key again, cubed, arrow out, minus 10x squared plus 24x. There's my next function, and the last one that we need the x-intercepts for this top table. Now, notice I don't have a great picture of my entire polynomial graph. I just see a lot of up and down lines. The only thing I care about are the x-intercepts. So I don't care that I can't see minimums and maximums here. I just care about the x-intercepts. So that's what I'm going to look at. So menu, oops, analyze graph, 0. I've got a 0 at -3. And just move that out of the way. Menu, analyze graph, 0. I've got one at the origin at 0, 0. I've got one at 2. And I've got one at 4. So those are my x-intercepts. They're -3, 0, 2, and 4. Let me put my calculator down and I'll fill in my x-intercepts on my paper. You guys should have yours filled in. So this is -2 and +2, -2, -1, and then -3, 0, 2, and 4. What do you notice about the degree and the number of x-intercepts? Yeah, so where a degree is 2, we had 2 x-intercepts. When it was 3, we had 3 x-intercepts. When it was 4, we had 4 x-intercepts. Okay, and we had a couple repeats in here, so 2 and 2, 3 and 3. Okay, the degree is the same as the number of x-intercepts. And I want you to notice that includes multiplicity. So for this guy, we said we would have -1 twice. We would have 2. Remember this squared? Another way to think of it is I would have another x - 1 as a factor. So I would get 1, 1, and -3. So that includes multiplicity. Okay. So if it's got an exponent, I have to count it that many times. But the degree is the same as the number of x-intercepts. That idea is what we call the fundamental theorem of algebra. Okay, fundamental theorem of algebra. So if whatever the degree of my polynomial, that's how many roots, we're going to see that term now, that's how many roots my polynomial should have. So if my function has a degree of 5, then it should have 5 zeros. Okay, so we're going to use sort of zeros, roots, to a certain extent, x-intercepts as being all sort of in the same family when we're talking about terminology. Okay, so your calculator calls them zeros. We're seeing the term roots here in this sort of formal mathematical definition, and we looked at x-intercepts up here. Okay, so the sort of difference between these, even though for a lot of what we're going to do, it almost seems like they're interchangeable. When we talk about functions, so when we've got that function notation, we would talk about zeros. So that's why your calculator calls them zeros. When we talk about equations, which is what we're going to focus on later in this unit, we're going to talk about solutions. Expressions would be if I didn't have that f of x equals and I just had this portion here, it wasn't equal to anything. That's what we call an expression. And so we use, or we should use the term roots for that. And then when we're looking at graphs, like we did when we graphed these, we talked about x-intercepts. So that's kind of how we define each of these terms and where we should use each of these terms. They're going to seem pretty interchangeable for a lot of what we're doing. Okay, just the context I'm using is what's going to be the difference in the term that I use. So we're going to do the same thing again with some more functions. We're going to start with the number of zeros I expect. So remember that this is going to be the same as our degree. Number of zeros expected. That should be the same as our degree, right? Because we just said the degree should be the number of x-intercepts, the number of zeros that we have. So how many zeros would I expect from this function? What do you say? Yeah, because its degree is 3, right? 2 and 1 is 3. How about from here? Yeah, 2 and 2 is 4. How about this guy? How about this guy? 4, right? Standard form, biggest exponent. And then this last one? Now let's take it to the graph. Okay, so we're going to graph each of these. Okay, let me pull up my calculator here. And I'm going to make a new page again. And we are graphing x squared minus 4 times x minus 1. Okay. What are my x-intercepts here? They're all at nice places. -2, 1, and 2. Okay. Let's go ahead and get this out of here. You hit the delete key 3 times. It does get rid of your graph. And then I could hit the tab key to bring my equation entry line back up. And let's graph the next one. This is x squared minus 1 and x plus 3 squared. Again, these are all at nice places. So I've got, looks like +1, -1, and then -3. Remember that -3 has a multiplicity of 2, so I want to list it twice. So +1, -1, -3, -3. Again, that multiplicity factors in. +1, -1, -3, -3. And then let's look at our next one. There we go. Okay, what do we have? X squared plus 3x plus 5. There's our parabola up here. What are our x-intercepts? There aren't any, right? It doesn't touch the x-axis. So for this one, I want you to write none. There are no x-intercepts. And then our next one, another x to the 4th plus x cubed plus 4x squared plus 4x. We've got, it looks like 2 x-intercepts here at 0 and at -1. Notice that these both have linear behavior, not the sort of quadratic that we saw for one of our earlier examples, not cubic behavior, but linear behavior. That means I would only list each of them once. So 0 and -1. And then my final function on page 1, x squared plus 2 times x minus 1 times x minus 4. I can see an x-intercept at 1 and an x-intercept at 4. So 1 and 4 are my x-intercepts there. Put my calculator away. Fill in my x-intercepts, which you guys already have written down. And then let's talk about what we saw. So we had -2, +2, and 1, -3 listed twice, then -1 and +1, then nothing for that middle one, then -1 and 0, then 1 and 4. So we said that the degree should tell me how many zeros to expect. So these were how many zeros I was expecting based on the degree. That matched up for this one and for this one, because remember that multiplicity is included. But the last three, not so much. Do we see that? I expected 2 because my degree is 2 and I didn't have any at all. Here I had 2, but I was expecting 4. And again, I had 2, but I was expecting 4. So did our x-intercepts match up with what we literally just said our x-intercepts should be? No, right? Okay. That doesn't mean that I lied to you. What it means is that there's something else that we're going to consider in this unit. There's sort of another factor at play here. Okay. So if we turn to the next page, the first thing I want to point out, and we talked about this already, is that that number of zeros includes multiplicities, okay, which we had listed. So we had already talked about that, and we included our multiplicities. But what we didn't have a way to account for were that some functions have what we call non-real or imaginary zeros. So we're going to start talking about those tomorrow, but that's the discrepancy that we're seeing. Okay, when we had that mismatch between the degree and the number of x-intercepts, it's because some of our zeros we're not going to be able to see on the graph. Okay, we won't see them as x-intercepts. And that's kind of what we're going to dive into tomorrow and the rest of this week. But that's where we're having issues. Okay. The thing that we'll be able to latch onto today, though, is how many imaginary zeros we should expect. Even though we're not quite sure what those are yet, what we do know is that there's always going to be an even number of them. They're always going to come in pairs, and we'll talk more about that tomorrow, why they come in pairs and what those pairs look like. But for today, if I have imaginary zeros, they're always going to come in pairs. So if we take a look at a couple more functions, how many zeros would I expect this first function to have? What's its degree? 2. So I would expect 2 total zeros. Graph this on your calculator for me really quickly. How many x-intercepts do you see? None, right? You shouldn't see any x-intercepts for this one. Or actually, I'm going to write none here instead of putting 0, because then that looks like 0 is an x-intercept. I don't want us to be confused. So x-intercepts, none. So that must mean if I don't see any x-intercepts, the rest of my zeros are what we're going to call imaginary zeros. Okay, so there have to be 2 imaginary zeros then. If I know there should be 2 total, none of them are x-intercepts on the graph. That means I have to have 2 imaginaries. If I take a look at my next function, how many zeros should this thing have? 3. Graph it for me. How many x-intercepts did you have for this guy? And where was it? Yep. So I have an x-intercept at -2. I have 1 real zero. How many imaginary zeros should I have then? 2. Okay. I have to have 3 total. One of them I can see as an x-intercept. That means the other 2 must be imaginary. What about my fourth function here? How many zeros do I expect? 4. 2 plus 2 gives me 4. Go ahead and graph that. How many x-intercepts do you see on that graph? 2, and where are they? -2 and +2. So I'm supposed to have 4 total zeros. I can see 2 of them on the graph. How many imaginaries would that leave me? And then for our final function here, how many zeros do I expect? Degree is 3. Go ahead and graph that. Any x-intercepts on this graph? Give an x-intercept at -1. So we've got 1 real 0. How many imaginaries would I have to have? 2. So this is what we're going to talk about tomorrow and the day after. This is where we're heading. More information on these imaginary zeros. What do they look like? How can I tell when I have them? But the last thing I want to talk about today is a little throwback to where we've done this same thing already. Okay, because almost everything that we're going to see in this unit, you've seen already in some capacity. So towards the beginning of our last unit, when we started to talk about factored form and finding x-intercepts from factored form, I gave you some problems like this. I said, assume your function has these, we call them x-intercepts, and I said, write a function that would have these x-intercepts. So we're going to do that same thing here. It's kind of a refresher of where we've seen this before. So the other thing I want you to do is assume least possible degree. So unless there's a reason to use an exponent, don't. Assume just the zeros I've given you and a leading coefficient of 1. So for my first function, I'm going to write factored form here. If I have a 0 or an x-intercept at 3, that means I had to have x minus 3 as a factor. If I have 0 as a 0 of a function or an x-intercept of the function, that means you could write x minus 0, x plus 0, or just x. And then if I have -2, that means I had x plus 2. As long as you have these 3 factors, any order is fine. So if you put your x in front, that's fine. And then finally, what's the degree for this function that we just wrote? What's the degree here? 3. And I actually could have answered that before we even wrote the function. These are the only zeros I have. I've got 1, 2, 3 of them, so the degree has to be 3. Let's try our second example here. F of x equals, I've got 1, so that had to come from x minus 1. And then I've got 1 listed again. What? Yeah, we can just square it. Yep. I would write the same factor again, so I can just square this one. And then I've got 5, so that had to be x minus 5. And then I've got 3, so that had to be x minus 3. What's the degree here? 4. 1, 2, 3, 4, or 1, 2, 3, 4. I want you to try the last 2. Check your work with mine. Questions for me for today? Okay. Your homework for tonight is page 3. Looks really similar to what we just did. So you have some functions. I want you to tell me how many total zeros you expect. Find any x-intercepts for the graph. I will tell you for a couple of these functions, you'll have x-intercepts that are not nice numbers. You're going to get some decimals for a few of these problems. Okay, so you will need to use the zero finder feature on your calculator. And then tell me, based on these two numbers, how many imaginary zeros you expect. And then write me some functions based on the zeros that you've got. Okay, so page 3 is your homework for tonight.